All right, this is lesson 7.1 test review. Number one here, a particle moves along the y-axis with the velocity given by this equation, v of t equals t squared minus 4t plus 3. That's in inches per second, and t has to be greater than or equal to 0. So we have a y-axis here. We have a particle on that y-axis, so it's going to be moving up and down. First thing I have to do is figure out when the particle stopped. So when the particle stopped, what's the velocity going to be? 0, right? When the velocity is positive, that means the particle is moving up. When the velocity is negative, that means the particle is moving down. So when the velocity is 0, that means the particle stopped. So all we need to really do is figure out when this function will equal 0. Just write it as v of t equals, let's factor that. T squared would be t times t. And what numbers multiply to be positive 3 but add up to negative 4? Negative 1 and negative 3. Yeah. So now, what times would make the velocity come out to 0?
1 and 3.
Right, so t equal 1 second, because our velocity is in meters or inches per second, so our time would be in seconds, and t equal 3 seconds. At those two times, the particle stopped. Now, it might be just stopped momentarily to change directions, or it could be stopped, pausing, and then going again, kind of like the stop and go at a stop sign. Any questions about part A? Part B. What is the total distance traveled by the particle during the first 3 seconds? Well, you need to know the formula for total distance traveled. Total distance traveled, you take the integral of the velocity equation, but you have to take the integral of the absolute value of the velocity equation, actually. So what we need to think about is when's the particle moving up, when's it moving down, and when's it stopped. So I'm going to make a little number line up here for velocity. Going from 0 to, let's say, 3 seconds. And we know at 1 second, the velocity is 0, and at 3 seconds, the velocity is 0. That's what we figured out right here. So these bottom numbers are times. The top numbers are velocities. So let's plug a number in between 0 and 1, like a half, or 0.5. If you plug 0.5 in here, you get what type of a number right here? Negative. Here you get a what? Negative. Negative times negative is a positive. So during that first second, the velocity is positive. That means the particle is moving which direction? Up. Yep. Okay, now let's plug in 2 seconds we can plug in any number between 1 and 3. Let's just use 2. 2 minus 1 would be 1. 2 minus 3 would be negative 1. 1 times negative 1 is a negative. That would mean the particle is now moving down. So the particle starts somewhere, it moves up and then back down during the first 3 seconds. Now, to figure out how far it moves, you have to do the integral. So let's do the integral from 0 to 1 of my velocity equation, which is t squared minus 4t plus 3 dt. This will tell us how far the particle moved up during that first second. So what's the antiderivative of t squared? 1/3 t cubed, correct. You make your exponent 1 bigger, and then you take 1 divided by 3 to get the 1/3. What's the integral of minus 4t? Right, minus 2t squared. What's the integral of 3? 3t. And since it's a definite integral, I don't need a plus a c on the end. I just need to put in my 0 and my 1 down. Which number do you plug in first? 1. Yep. Plug in 1 here. 1/3 times 1 cubed minus 2 times 1 squared plus 3 times 1. Figure out that answer. Then plug in 0. So 1/3 times 0 cubed, which would be 0, minus 2 times 0 squared, that would be 0, plus 3 times 0, that would be 0. So this is going to come out to 0 when you plug in a 0. So this would be 1 times 1/3, this would be 1/3 minus 2 plus 3. If you wanted to, you could put it all in thirds. If that helps you do it without a calculator here. You should be ready to do something like this without a calculator. 2 is how many thirds?
6.
That's 6 thirds, yeah. How about 3? How many thirds is 3? 9 thirds, good. So if you do 1 minus 6, that's negative 5, plus 9 would be 4 thirds. And what would be the label on that?
Inches.
That's
Inches.
inches. Just inches. This is, we're figuring out how far the particle moved. Okay? So this is in inches. You have to realize we're looking at a graph here. Let me see if I can give you a picture of it here. It looks probably something like this. Oops, take that back. This is my velocity graph. This is my time graph. We know that it's going to hit zero, velocity of 0 at 1 and 3. So at 1 and 3, the velocity is going to be 0. And at t squared, that's a parabola that opens up. It's going to go something like this. What we just found is this area right here. Remember, this is in inches per second. And this label down here is in seconds. So when you're finding area, you multiply the two dimensions to get the label on the area. So what do you get if you take inches per second times seconds?
Inches per second.
No, times. Inches. Yep. If you take inches per second times second, it's going to cancel out. Here you're dividing by seconds, here you're multiplying by seconds, so you just get inches. Okay. All right, so that tells us the particle starts by going up 4/3 of an inch. So it goes this direction, 4/3 of an inch. Now we need to figure out how far it comes back down between 1 and 3 seconds. So now we do the integral from 1 to 3. The same velocity equation. So we already know the antiderivative is 1/3 t cubed minus 2t squared plus 3t. But this time we're going from 1 to 3. I'm erasing this just to get this out of the way here a little bit. Okay, plug a 3 in here. Let's do some of this in our head. What's 3 to the 3rd power? 27. What's 1/3 of 27? 9. Plug a 3 in here. 3 squared is 9 times 2 would be what? 18. 3 times 3 would be 9. Minus. Now plug in 1. Let's see, we already plugged in 1 here, didn't we? What do we get when we plug in 1? 4/3. So let's just, if we plug 1 in here, we know from over here we're going to get 4/3. There's no reason to do that work over since we've already done it. 9 minus 18 is negative 9, plus 9 would be 0, minus 4/3 would be negative 4/3 inches. Why did I get a negative? It's moving down, yeah. So let's answer our questions now. What is the total distance traveled by the particle during the first 3 seconds? Well, if it moved 4/3 of an inch up, then it came back down 4/3 of an inch. What's the total distance that it traveled? 8. The total distance traveled would be 8/3, because it went up 4/3 and down 4/3, so it went a total of 8/3 inches. 4/3. So notice what I did is I took the absolute value of that second. We ignored the sign here, because we don't care which direction it goes, we just want to know how far it went. Kind of like if you go for a jog, who cares which direction you go, it's just how far did you jog. So together you get 8/3 for that answer. 8/3 inches. Part C. What is the displacement of the particle after 3 seconds? 0. Displacement is the distance between the starting and stopping points. It would start and stop at the same place. If it went up 4/3 and down 4/3, displacement would be 0 inches. Any questions about those last 2 answers? Part D. If the initial position of the particle is given by y of 0 equals negative 2. So what we're saying is that the particle starts off at a y-coordinate of negative 2. This means at time 0, the y-coordinate is negative 2. What is the position of the particle after 3 seconds? Negative 2 again, yeah, because it goes up 4/3, down 4/3. It'd be back to the same place that it started. So y of 3, after 3 seconds, the y value is going to be negative 2 again. Any questions about that? So be prepared to do